Okay, we are on momentum and impulse, and today we'll only be focusing on impulse. Okay, before I define what impulse is, I know the definition is written on screen, but before I define what impulse is, I want you to recall the things that we have learned in the past. We have learned that the net force acting on an object is equivalent to the change in momentum of that object over the time of contact, or yeah, over time. This was momentum. This was the second law, Newton's second law of motion, expressed in terms of momentum. You still remember from the previous lesson. So let's now try to reorganize this. Let's now make our numerator here. Let's now make our numerator, or our change in momentum. Let's make our change in momentum the subject of the formula. This means that we will have something like this. We will have something like this being equal to change in momentum over change over time. For us to remain with momentum only this side, we need to multiply both sides by change in time. If we are to do that, we will have this, and also this side we will have this. And when we have this one will cancel this one, and this one will remain. Then we will simply have F net force by time is equivalent to change in momentum. It will be equivalent to change in momentum. But if we only consider the left hand side, if we consider only this left hand side, if we consider only this thing, only this F net by change in time, we will now have something we call impulse. And what is impulse? What is impulse? What type of physical quantity is impulse? Impulse is a vector. Impulse is a vector. And why do we call impulse a vector? We call impulse a vector because it contains both the magnitude and the direction. Where do we get the direction for this impulse? We get the direction from the force. Force has a direction. Impulse, time is a scalar, it has no direction. So overall, impulse becomes a vector. So now that we have revised our concepts, let's now go to the definition. Impulse is defined as the product of the net force acting on an object and the time the net force acts on the object. Net force acting on an object and time, that gives us this impulse. It gives us impulse. And the units for impulse are newtons seconds, because force is in newtons, time is in seconds. So now that we know that this is equivalent to impulse, and at the same time this is equivalent to change in momentum. We can say that impulse is just a change in momentum. Impulse is just a change in momentum. You can still say that impulse is the change in momentum, and immediately we say that impulse is change in momentum, we now refer to it in terms of the impulse momentum theorem, Okay, at the same time, if we are to pay attention here, we know that our impulse here, is equivalent to our change in momentum. And we can all agree that our impulse will be equivalent to the change in momentum like this, will be equal to the change in momentum like this. Now let's go and look at an example. Here's an example. For this example, I will choose my west as positive and east as negative to make my calculations easier and more understandable. Okay, a car of mass 800 kilograms traveling at 20 meters per second east collides with a truck of 3,000 kilograms traveling at 12 meters per second west. The collision lasts for 0.5 seconds. After the collision, the truck is moving at 4 meters per second west. Calculate the impulse provided to the truck during the collision. Okay, let's look at it like this. Let's start. We have this powerful formula. We have that our impulse here is equivalent to our change in momentum, and at the very same time our impulse is equivalent to the final velocity in a final momentum by initial momentum. Now, before we continue, we need to understand something. We are calculating the impulse provided to the truck. Which means that the mass that we are going to use in this formula is the mass for this truck. The mass you're going to use is the mass for this truck. The time you're going to use is the time of contact of this truck here. The velocity, the initial velocity you're going to use is this 12 meters west, and the final velocity, the initial velocity is this 12, and our final is this 4. So now, let's calculate. We won't even have to use time. We won't even have to use this time because we are looking for impulse, and this entire term that contains time in it is, before we forget, this entire term is impulse. So this thing will now be equivalent to 3,000. My final velocity is 12. No, not 12. My final velocity is 4, and it's moving towards west. So I will just put it as 4 because it's positive. Then I will also have 3000 this side, and then my initial velocity is still going to be 12 positive. It's still going to be 12 positive. That's the reason I chose this. I chose my west as positive, because both the directions are in the both the velocities are in the same direction. Both the velocities are in the same direction. And having this, I will have 12,000. I will have 12,000 subtracting 36,000. I will have 12,000 subtract, and I will remain with negative 24,000. Because this is impulse, I will have newtons second. The direction is going to be the opposite direction, which is east. This opposite direction, and this is our impulse, and this is our impulse. So in this condition, each object involved in the collision experiences same net force. Both these objects, they experience the same net force. We have covered this in the previous lesson. We have covered this in the previous lesson. They both experience the previous lesson. I'm not referring to the lesson of impulse, the lesson before impulse, and I mean the lesson before elastic and elastic collisions. The net force is the same for both objects, but in opposite directions according to Newton's third law. Another thing is that time is the same for both objects. Time is the same for both objects because it's the time of collision, and therefore the magnitude of the net force on each object is the same, and the contact time is the same. Therefore the object experiences same impulse but opposite in direction. So if in this case this is the impulse for our truck is negative, it means that the impulse for the car, this is impulse for the truck, the impulse for the car will be positive 24,000, not 2,000, 24,000 newtons per second west. And another important fact about another important fact about collisions, before I conclude this lesson, another important fact about collisions is that each object involved in the collision will experience an equal but opposite net force. That's the first one. The second one is that each object involved in the collision will experience an equal but opposite impulse also. The third one is that each object involved in the collision will experience an equal but opposite change of momentum. Equal but opposite net force, equal but opposite impulse, equal but opposite change in momentum. And this concludes our lesson for momentum and impulse. We have covered everything in the chapter for momentum and impulse. Any video that will be linked to momentum and impulse that I will post, it will be on tips on how to solve momentum and impulse problems. The other one will just be revision on momentum and impulse based on previous question papers. The revision will be based on previous question papers. Even the tips will be given to tackle exam-based questions. Other than that, we are done with this whole chapter.